The other thing that a rigorous test framework gives you is again, the knowledge that you are passing your requirements, that when you create a new piece of code, that it's tested well enough that you know you could push it live. And so the next logical step then is to not treat releases as this big ceremonial thing, and especially with web deployed or with modern infrastructure, it's much easier to actually continuously deploy things to users. By being able to run the tests in an automated way and know that you have passing code, it makes it much safer then to take those little tiny incremental changes and push them live to site, push them out to customers. And what that does is it reduces risk. The likelihood that you're on the wrong track goes way down if you're measuring it all the time. Like if you push something out to users and you find out that it breaks, then you can roll it back right away in this tiny, tiny increment, like this little tiny. Then we know also if your release is 1,000 lines of code or 10,000 lines of code or 1,000,000 lines of code, and something breaks, then you have to look through all that code to figure out what happened. But when the change set is just, I made this tiny little change and it broke something, then you know from actual user experience that it's pretty obvious what the thing is. You can go look in this little tiny thing, resolve it really quickly. First of all, you can roll it back quickly, and you can resolve it really quickly, and then move on. When people talk about continuous integration, they mean a lot of things. I will often talk about continuous releasability and the idea that every time something's checked in, it could be pushed live. The best functioning teams, in my opinion, are the ones that really do push every time something's checked in to the source code repository, it gets pushed live to site as part of the regular deployment process. And when you get to that state, that means you're releasing, 10, 100 times a day, depending on the team size, obviously. But as a typical developer, I think it's healthy for a developer to be checking in, every few minutes, right? They make a little change. As soon as they have an increment of valuable code, it should be checked in so that it's shared as broadly as quick as possible. And so in that kind of situation, you may be deploying tens or hundreds or thousands of times a day, depending, again, on the team size, how many people are deploying. Certainly, you don't want stuff sitting around for a week or a month. And traditionally, you might have, like old software projects would have 6-month or annual release cycle even. So you'll have all this sort of validation debt that you've accumulated. You don't know if this stuff actually works until you push it live. And when you're actually pushing live, the best is if you sort of do an incremental deployment too, and sort of push to, what Google calls canaries. Different people call it different things, but the idea of pushing to 1% of your infrastructure. So you can also use feature flags or other mechanisms for sort of saying, I only want to expose this new behavior to a small fraction of my user population. You get then a little bit of confidence without exposing a lot of your users to the new code that it's working well. And then once that's been validated, you can push it across more and more of your cluster, usually pretty rapidly. And you may still, and what you find is that by doing rigorous testing, the number of defects that actually make it to production are very, very small. But you still will have some that make it to production. So then you've narrowed who is exposed to those production issues. You take those, anytime you do get a production issue, you write a test. First you roll back the change, and then you write a test that demonstrates the behavior, the off behavior that you saw, and validates that that the code doesn't do that. And obviously at this point it does have the defect, so it should fail because it doesn't. It's not that defect still exists. And then you fix the defect, and then the code prevents you from recreating that defect in the future.